In this question, I recommend a diagram and just trying to draw these things out. You might be interested to know how you do it without a diagram, but actually a diagram is a good idea to gain insight into this. So we can't use a ruler, so we're just going to have to do our best to draw some axes and then some straight lines. Okay, this is 0, 0, 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. And I've got some different points on here that I'm interested in. 6, 2, 3, 4, and 5. And we want to know which of these are not hidden points and which ones are. So what this is saying is that 2, 2 is hidden because I can see 1, 1, but then as I go through, I'm not going to be able to see this point here. And the question is, which of these can I see? So I'm going to have a look at this. If I go along 6 and up 2, actually that means I'm going to go along 3 and up 1. I am going to see that point there. But then if I carry on, I'm actually not going to see that point. So this one is hidden. I want to know how many are not hidden. Let's look at the next one, 6, 3. So for that one, I'm going along 6 and up 3. Actually, that is the same as going along 2 and up 1. Along 2 and up 1, along 2 and up 1. This one is also hidden. Six, 4. Actually, I'm going along 3 and up 2 now. Along 3 and up 2, along 3 and up 2. So this one is hidden as well, which just leaves us with 6, 5. And actually, that one, there's nothing that goes into 6 and goes into 3. This one will be visible. And so the answer is 1. Now, an interesting question is how can you tell without drawing the graph? And I'm not going to, go into lots of detail on that, but I'm going to talk a little bit about it. And you can see that here, the gradient of the line, well, it's rise over run. It was 2 over 6, but I could simplify that because they had a common factor, and it's also 1 over 3. That meant it was hidden. For this next one, it was 3 over 6, which simplified to a half. And then 4 over 6 simplified to 2 over 3. So you can see all these ones that are hidden are when I can write it using the gradient. I could write it as 6 over 4 instead, but I've gone with the gradient because that's rise over run. That's a known quantity. And then finally, when we got to 5 over 6, I can't simplify it, which means it's not hidden. So that's going to be working in general. That's again why 2, 2 was hidden, because 2 over 2 is the same as 1 over 1, same as 3 over 3, and so on. So all of these here would also be hidden. So that's a little insight into it. I would recommend investigating this problem. It sounds like a good one. How can you, look at the extended solutions to this challenge, and it will talk a bit more about it. How can you do it for larger values of x and y? How can you generalize it to m and n? Neat problem. Have a go.